Lesson 3 is properties of limits. Topic 1.5, determining limits using algebraic properties of limits. The purpose of this lesson is to think about the way limits can be combined if you're dealing with different functions. And so we'll be representing them with F, G, H, and whatever other letters we need to use. So there's some basic properties that we want to understand before we actually come up with our rules to calculate limits. So our limit properties are as follows. B and C are real numbers, and n is a positive integer. So f and g are our functions. The first one listed is that the limit as x approaches c of k is k. So in other words, the limit of a constant is that constant. And if we were to look at that on a graph, what we see is if we're taking the limit of a constant, we're taking the limit of a constant function, and that function would be a horizontal line. So any x value you pick, so wherever your c is, it is always going to have a value of k. The next one is the identity rule. And if you're just dealing with the limit of x as x approaches c, you're going to get that value of c. The third one is the coefficient rule. And what we're saying here is it's a coefficient. It does not change regardless of what x value you're approaching. So you can take the limit of the function first, and then once you find that limit, you can multiply the coefficient times the limit instead of the coefficient times the function. Next is the sum or difference rule. And as you'll see, we're taking the limit of f of x plus or minus g of x, one or the other. That's why we call it the sum or difference rule. And what we're showing is we can take the limit of each individual function. So we can take the limit of f as f approaches c, and x, not f. We can take the limit of f as x approaches c and add or subtract to that, depending on the problem, the limit of g as x approaches c. And we will use that quite a bit when we are talking about polynomials. So we can treat each term of a polynomial as its own separate function. So something like x to the third plus x squared plus x, we can think of these functions as f, g, and h. So we can take the limit of each one separately and then add those limits together. That's going to come into play quite a bit. Okay, the next couple properties, we have the product rule and the quotient rule. So it's the same idea as the sum and difference rule. So you're multiplying two functions together, f and g, and taking the limit of that as x approaches c. What you can do instead is first take the limit of f and then take the limit of g as x approaches c and multiply them together after you take the limits. The quotient rule is the same idea. You have the limit as x approaches c of the quotient f of x over f of c. But if you take the limit of each one separately and then divide the values of those two limits, you'll get the same value. But please remember, you have to be careful and make sure the limit of g as x approaches c is not equal to 0, because then we have a special case, and we'll get into that in the next lesson for some things. Okay, and then finally, our last three rules. I'm going to do 7 and 9 together and then come back and do 8. They kind of go together a little more. Our power rule says if we have a function raised to the power, we can take the limit of the function first and then take the power. And remember, n is a rational number. And the root rule is very similar, but now instead of raising something to a power, we're taking the nth root. So instead of taking the nth root of the function and then taking the limit, we can take the limit, and then once we do the limit, we can take the nth root of that value. And this is important. You want to make sure that the root exists on the right side. So that's going back into our one-sided limit. So we want to be careful of that. And then finally, our last rule is our composition rule. If we're composing f of g of x, instead of doing this, what we can do is we can take the limit of g, whatever that value is, that's our L, and then we can take f of that value, and it'll be exactly the same as if we took the limit of the composition. Okay, so it is important to be able to talk about these rules and be able to say them in English so you understand what you're working with. Because down the road, very shortly, we will have to work with these quite a bit. Okay, so let's do an example here. We're supposed to use the properties of limits to find each of the following limits. If the limit does not exist, state why. Okay, so we're going to do this from a graph because we don't know what the functions are exactly. They're not explicitly stated, just represented by f of x and g of x. So the first one says the limit as x approaches 3 from the right of f of x plus g of x. So when we're looking at this, what we want to do is take a look at the f graph and take the limit as x approaches 3 from the right of f of x. And then we're going to add to that the limit as x approaches 3 from the right of g of x. And we can just add those two limits together. Okay, so first looking at the graph of f, we're going to find 3, and we're going to come towards 3 from the right-hand side, and we reach a value of 6. And then we're going to look at the graph of g, which is right here, and we're heading towards towards 3 from the right. So we're going to follow along this way, and we reach the value of 8. So the limit as x approaches 3 from the right of f of x plus g of x is 14. Okay, doing the next one, the limit as x approaches 5 of 3 times f of x minus 2 times g of x. We can write this again, rewrite it with our properties. This is the same as saying 3 times the limit as x approaches 5 of f of x minus 2 times the limit as x approaches 5 of g of x. So we'll get both of those values off the graph, and we'll go from there. Okay, so we have 3 times, and the limit as x approaches 5. So as we go to 5, what we see is that we have a value of 2 right here, a value of 2. Subtract from that, and our limit as x approaches 5 of g is going to be right here, and that value is 4, so we're going to have 2 times 4. So we have 6 minus 8, and we get negative 2. Okay, so next one, the limit as x approaches negative 5 from the left of f of x minus g of x. Rewriting those, we get the limit as x approaches negative 5 from the left of f of x minus the limit as x approaches negative 5 from the left of g of x. So looking at our graph of f, negative 5 from the left would be this way. So we have that value right there, which is negative from the left, not the right. Sorry about that. From the left is this way. So we get the value of 3 minus value of g of x as x approaches negative 5 from the left. So we come this way, and we're approaching negative 5 from the left, and we're at that hole there, which is at 4. So we get 3 minus 4, which is negative 1. Okay, and finally the last one, we have the fraction. Well, not the last one. Last one that I'm going to do, you guys can do the other ones, and I'll just list the answers. The limit as x approaches negative 7 of 3 times f of x divided by g of x. So again, we can rewrite that. And that's going to be 3 times the limit as x approaches negative 7 of f of x divided by the limit as x approaches negative 7 of g of x. So looking at our graphs one more time. So the value of the limit at negative 7 for f of x. So moving back up here, erase some of this off here. When we look, negative 7 is here. The value of the function is 5, so we are right here. And when we look at g of x, I'll write that down in just a second. As we approach negative 7, we are right here at 3. If I can get it to work. I'm on the eraser still. At 3, right there. So writing that down, we have 3 times 5 that we found on the graph divided by 3, which gives us a limit value of 5. Okay, so what I would like you guys to do is stop the video, take a moment to do the last 6 here, and I'm going to list the answers here in just a second and check your work. And then if you have any questions, we can go over them in class.